Section 2, techniques for evaluating limits. First, we need to understand the fractions. If you take 0 and you divide it by a non-zero number, the answer you get is 0. Remember that if you have 8 over 4 equals 2, and it must be the case that 4 times 2 equals 8. In fact, if you didn't know what 8 over 4 equals, you can ask yourself, 4 times what gives you 8? That is equals 8. The answer is 2. A non-zero number times 0 will give you 0. This number in this box has to be 0. Okay, so 0 over not 0. 0 over 7 is 0. 0 divided by negative 2/3 is 0. 0 divided by the square root of 11 is 0. So long as the bottom number is a number and it's not 0. 0 divided by 0.00314. That's 0. You need to know that, and most of you do. If the top and bottom are both not 0, like 8 over 3, well, in this case, 8 over 3 is 8 over 3. But if you had 14 over 21, you can say 7 goes in here 3 times, about 2 times, excuse me, and 7 goes in here 3 times. So 14 over 21 is the same as 2/3. So other than reducing, if you do a limit and you get 0 over 7, then the answer is 0. If you get 0 over negative 2/3, it's 0. If you get 8/3, it's 8/3. It's 14 over 21, then just reduce it. What if you have 0 over not 0? What does that equal? Like for example, you have 8. But unfortunately, I said and wrote these backwards. Sorry. Suppose you have a non-zero number. You want to divide it by 0. Like you have 8. That's not 0. When you divide it by 0, what do you get? Well, better answer this question. 0 times what number equals 8? Well, if you multiply 2 numbers and one of them is 0, then you don't even have to hear what the second one is. It's 0. Even if you couldn't make out the second number, if I ask you what 5 times is, well, you don't know what you're multiplying 5 by. You see, it was not clear. It's really 5 times 4. But with 0, you don't have that problem. If I ask you what 0 times, and then the number I say is not clear, you still know the answer is 0. There's nothing to put here. We call this undefined. 8 divided by 0 is undefined. And if you got a limit and it was 8 divided by 0 or 18 divided by 0, you were done. You would say the limit is undefined. Not 0 over 0 is undefined. Let's do some limits that look like the cases we just talked about. The different types of fractions we spoke about. Where you had 0 on the top, where you had 0 on the bottom, where you didn't have 0 on top or the bottom. Somebody going to do this problem. What is the limit as x goes to 3 of 2x minus 6 over 7? You should always substitute this number in here for that letter. So substitute 3 for x. 2 times 3 is 6. Take away 6 over 7. 0 over 7, that's 0. 7 times what gives you 0? 0. So that problem is done. The limit is finished. What if you have the limit as x goes to 5 over x plus 2 for x minus 5. Wherever you see x, you can put brackets, and inside those brackets you put 5. And here you get 7 over 0. Not 0 over 0. This is undefined. 0 times nothing gives you 7. That is why it is undefined. It being this limit. Because this limit equals this, which equals this, which is undefined. The limit is undefined. We have a limit as x goes to 3 of x plus 3 over x plus 6. Wherever you see x, put 3. And you can write x plus 3 over x plus 6 and put 3 inside the brackets. And you'll get 6 over 9. 3 goes in here 2 times. 3 goes in here 3 times. 2/3. Okay, other than maybe reducing, once you substitute, you're done. With one exception. Now, before I get to that exception, I want to do one more problem. A lot of people, our math instructors will tell you, oh, you see a problem like this, the first thing you do is factor. That's not true. You may not need to factor. You may not need to factor. Instead of x, you plug in 3. So you have 3 squared, which is 9, plus 3 times 3, which is 9. You have 2 9s, which happens to be 18. In the bottom, you have 3 squared, which is 9, plus 5 times 3 is 15, plus 6. 9 and 6 is 15, plus another 15, that's 30. Adding in that order was more friendly for me. I know my 6 times table, and most of these numbers are on a 6 times table. That is, 6 goes into 18 3 times, and 6 goes into 30 5 times. So the limit is 3 over 5. Just directly substitute. Here's the answer. Just have to clean it up. Except when you get 0 over 0. 0 over 0. That's the only case we didn't get. We didn't talk about. We talked about 0 over not 0 equaling 0. We talked about non-zero numbers divided by 0. That is called undefined. And we talked about not 0 over not 0. It just equals itself in reduced form. And now we're going to talk about 0 over 0. Well, we have a rule that says 0 divided by any number is 0. So on one hand, one can say that's 0. On the other hand, if you divide the same two numbers, you should get 1. In fact, they both check. That 0 and 1 both check as an answer. 0 times 0, yes, it equals 0. 0 times 1, yep, it equals 0. So 0 over 0 equals 0, and it equals 1. And there's no reason why it wouldn't equal negative 2/3. 0 times that number, I don't care what it is. certainly equals 0. So 0 over 0 can equal any number. At least that's what it seems. But there's a problem with that. Suppose, since 0 over 0 can equal any number, it certainly equals 1, and it certainly equals 8. Well, 5, for example, is 5 times 1, which is equal to, that is 5 times 1 is equal to 5 times 1. But that's 1. 0 over 0 is 1. So this equals 5 times 0 over 0. There's my 5 times, but 0 over 0 is 8. And 5 times 8 is 40. So 5 is equal to 40. If you take a test and your teacher finds 2 problems that are correct and they're 5 points each. So you get, your teacher claims you get 5 plus 5, which is 10. You got a 10 on that test, so 10%. And of 100, you got 10. Well, nobody really said it was out of 100, but let's assume it was. Mainly because I want to argue this now. You can go to your teacher and go, oh, no. Teacher, I'm sorry. I did a lot better. 5 is 40. And that other 5 I got is 40. And 40 plus 40 is 80. Okay, now, this is absurd. You can't have a valid argument where your 10 points should be 80, or if you owe me, if I owe you $10, you want me to give you $80 because they're equal. We can't have this. We can't have 5 equaling 40. That is, we can't have 0 over 0 equaling any number. We cannot have 0 over 0 equaling any number. 0 over 0 is indeterminate. 0 over 0, we call this indeterminate. Okay, so you have 0, you have undefined, you just have a regular fraction. Now you have indeterminate. And 3 of the 4, with this being the exception, all the others have 0. The first one has 0 on top, the second one has 0 on the bottom, and the last case has 0 top and bottom. Top and bottom is when you run into trouble. Now, normally, if somebody just gave you a straightforward problem, 7 minus 7 over 2 squared minus 4, well, the top is 0, 2 squared is 4, take away 4 is 0, you would say that the answer to this is indeterminate, which is correct. Now, when it comes to limits, we can always determine it. We can always figure out what 0 over 0 is. Sometimes 0 over 0 is 11. Other times the limit that gives you 0 over 0 equals 24 or negative 98. I can give you a limit that when you substitute, you give me any number. You give me any number. I'll give you a limit where it's 0 over 0. But when you do figure out what it is, it'll be 11. Is the number that you want me to get. Now, before, so that last problem, I don't know if I stressed it enough, but this last problem, I mentioned at the beginning that you didn't need the factor, and maybe I lost track of that. Well, I mean, just look, we got the answer right away. 9 plus 9 over 9 plus 15 plus 6. We got the answer right away. Not a hard thing to do. So you didn't need the factor. This sometimes you do have to factor. If the numerator and the denominator well, no, let me go over this first. Let me go over this concept. A lot of you will tell me that x over x equals 1. This is not true. This is why you had trouble in intermediate algebra class. Kept getting erroneous answers because you said this was 1. It's not true. So long as x is not 0, but they're the same. The top and the bottom are the same, but they're not 0. Yep, you get 1. But you know what? If the top and the bottom are 0, if x is 0, then you have 0 over 0, which is indeterminate. You can't cross it out and say it's 1. Now, if you have, say, x minus 7 over x minus 7, we're going to have a similar situation. Sometimes it's going to be 1, and sometimes it's going to be indeterminate. The question is, when? Well, it'll be indeterminate when these are 0. First of all, they're both the same. That's why sometimes it's going to be 1. As long as the top is not 0, it'll be 1. That means x and 7 have to be different from one another. X can't be 7. Otherwise, you'll have 7 minus 7. That's the condition to get 1. Not x is 0. A lot of people will say, oh, it equals 1 when x is 0. Not true. When x is 0, I get negative 7 on the top. I get negative 7 for the denominator. 0 minus 7 is negative 7. And negative 7 over negative 7 is certainly 1. But when x is 7 itself, when x is 7, 7 minus 7, 0. Divided by the same thing, 0. That's indeterminate. It's indeterminate if x is 7. So be careful about crossing things out like that and calling it 1. It may not always be 1. It may not always be 1. But I needed to mention it. But in limits, it really doesn't matter even if you forget this rule. It's not good that you forget it, but fortunately you won't make any mistakes. So here's a problem where when you directly substitute, and you should always, always, always directly substitute. So only sometimes you'll have to do additional stuff, and that's when top and bottom is 0. So x is 5. 5 squared is 25. Minus 25 is 0. X is 5. 5 minus 5 is 0. This is indeterminate. So we need to do something to determine it. And since the top and the bottom of the fraction, top and bottom, numerator, denominator, are polynomials, we can factor. And I guarantee you, for numerator and denominator, this minus that, x minus 5, will be a factor for the top and the bottom. Top is x plus 5, or x minus 5 times x plus 5. The bottom is just x minus 5. Now, here's where something's neat. The only time this is not equal to 1 is when x is 5. 5 minus 5 is 0 over 5 minus 5 is 0. Okay, that's not 1. That's not 1. Okay, when x is 5, this is not 1. But if x is not 5, it is 1. 7, if x is 7, x minus 5 over x minus 5. Oh, that's 2 over 2 or 1. As long as this is not 5, it's 1. But x is approaching 5. X is approaching 5. It gets really close to 5. From above 5 and even below 5. But you know what's really nice? It's never 5. I'm Among other things, this tells me x is never 5. That means this is 1. This is 1. Okay, so Dennis did that great, but otherwise we factored in, we canceled. And now let's write down what we have left. Just the x plus 5 survived, and we directly substitute. 5. 5 plus 5. X is 5. 5 plus 5, 10. You're done. You get 0 over 0, 0. When it comes to limits, you have to do something to determine the exact answer. For example, here we had 0 over 0 being 10. For limits, the possibility for 0 over 0 is any number, or every number. You have to figure out which one it is. This is the only time where limits are less than friendly. You have the limit as x goes to -1 of x squared minus 2x minus 3 over 4x plus 4. So we substitute this number for that letter. We substitute -1 for x. So it's x squared minus 2x minus 3 over 4x plus 4. And x happens to be -1. Okay, -1 squared is 1. -2 times -2, positive 4, minus 3. X is not -2, excuse me. The plus 4 is wrong. X is -1. X is -1. And -2 times -1 is plus 2. And then, like I wrote above, minus 3. But that's 0. 1 plus 2 is 3. Minus 3 is 0. In the bottom, that's -4 plus 4. That's 0. So when it comes to this equals the limit, so now we're back to pre-substitution. We're not substituting. What I'm writing here will not have -1 substituted for x. That's where I have to write limits again. Now, x minus that number, x minus -1, x plus 1 must be a factor. If -1 makes the numerator and the denominator are polynomials. If -1 makes them 0, then x minus -1, also known as x plus 1, will be a factor. So one of the factors of the numerator is x plus 1. And if you want to end up with -3, I bet you should try x minus 3, because 1 times -3 is -3. Okay, in the bottom, I can factor out an x plus 1 by factoring out. I can get a factor of x plus 1 by factoring out the 4. Okay, so x minus -1, that is x plus 1, is a factor of the bottom as well. Since x will never be -1, this will negative be 0. This will never be 0. This will never be 0 if x is not -1. But they're the same. So when you divide them, they cancel out. So we have the limit as x goes to -1 of what I didn't cross out. X minus 3 over 4. Plug in this number for that letter right here. -1 minus 3, which is -4, divided by 4 is -1. Here, 0 over 0 was really -1. If the numerator and the denominators are polynomials, and you're getting 0 over 0, then you have to factor the top and the bottom. you undo 0 over 0, and we just undid 0 over 0, 0, and we got 10. Once you undo it, you might get 0, you might get undefined, or you might get 10. You just won't get indeterminate again. Well, actually you could, but it wouldn't be your final answer. You would have to factor some more. And I keep saying factor. You get 0 over 0, you factor. Guess if the top and the bottom are polynomials. Well, you should know that 4x is 4. 4 minus 4 is 0. 5 times 0 is 0. So either the answer is 0 or it's indeterminate. Well, let's see what the bottom is. 4 squared is 16 minus 8 times 4 is 32 plus 16. Well, 16 plus 16 is 32. Take away 32, you get 0. So we have 0 over 0. You should look at the top and the bottom. They are polynomials. So you can factor them. And one of the factors will be this minus that. That is x minus 4. And what do you know? It's there in the top. You make it up. There it is. You don't even have to work hard for it. In the bottom, you have x squared minus 8x plus 16. I guarantee you, if you factor this, one of the factors will be x minus 4. Well, what should the other factor be? Well, negative 4 times what gives you positive 16. The answer is negative 4. And if you FOIL it out, if you FOIL this out, you'll get x squared minus 8x plus 16. In fact, it's a perfect square in this case because half, there's an unlisted 1 in front of the x squared, and half of the negative 8, which is negative 4. That squared, 16, is what's being added on. Okay, so we can factor the bottom. If you factor enough, you won't get 0 over 0 anymore. You have the limit. You don't really have to write this down. You should see it's 5 over 4. Excuse me, 5 over x minus 4. And when you directly substitute, the top is 5 and the bottom is 4 minus 4. You get 5 over 0, which in this case is undefined. And you're done. You're only not done when you get 0 over 0. Here's the case where 0 over 0 was undefined. 0 over 0 in the end can turn out to be anything. 11, undefined, negative the square root of 3, 0, 9 over 4, can be anything. Now I keep talking about polynomials. Well, here's an example, a limit, where we don't have polynomials. Take the limit as x goes to 25. Now it's not a polynomial because the power of x can only be 0 or 1 or 2 or 3 or 4, etc. to be a polynomial. And the square root of x, the power, is understood to be half, which is not any of these infinite numbers. These allowable numbers. You can be 0 or 1 or 2, you being the power. The power of the variable can be 0 or 1 or 2 or 3 or 4. Not negative 5, not 2/3, not 1/2. Okay, nonetheless, when we substitute in, we get the square root of 25, which is 5, minus 5, which is 0, divided by x is 25 minus 25 is 0. So we need to do something. Now, if you look at the numerator, if we square this, we get x. And if we square minus, and if we square that, we get 25. Exactly what the bottom is. Now, the question is, how do you just come in square? Please, a minus b squared is not a squared minus b squared. If you square the square root of x minus 5, if you were to square this, you do not get the square root of x squared minus 5 squared. You do not get that. Remember, there's another term. But there is a way to do this. There is a way to do this. If you have, it's called conjugates. If you have a minus b, and you multiply by a plus b, the answer happens to be this squared minus this squared, or this squared minus that squared. So there is something to multiply the square root of x minus 5 by to get x minus 25. Okay, let's put this into action. If you want to change the way something looks, I want to change the way that numerator looks. If you want to change the way something looks, you multiply by 1. You want to change the way something looks, very simple. You multiply by 1. And what's in that bracket, I want to change the way it looks. So I multiply by 1. But there's many ways of writing 1. Say a fraction that's 1. How about the square root of x plus 5 divided by the square root of x plus 5? Now for the record, since x is near 25, this will never be 0 over 0. In fact, the square root of x cannot equal 0. Because if this plus that equals 0, then this must equal negative 5. But that can't be. The square root of nothing is negative. Okay, nonetheless, we do the multiplication only for the numerator. The bottom is just x minus 25 times the square root of x plus 5. And the top, they're conjugates. This is a, this is b, that's a, that's b, plus minus. We're supposed to get a squared minus b squared. A is the square root of x. You square it, you get x. Minus b is 5. You square it, you get 25. And the reason you didn't want to multiply out the bottom, even if you could, is because you want it in factored form. Now I see that this is 1. Remember, it's only 1 when x is not 25. So x of 25 is 0 over 0. But it's not 0 over 0. Because x is approaching 25. It's not 25. So it's just 1. So you get the limit as x goes to 25 of 1 over the square root of x plus 5. Well, 1 is 1, and x is 25. The square root of 25 is 5, plus 5. 5 plus 5, 10. Minus some silly error, 1 over 10. So here, the clear example where 0 over 0 was 1 over 10. So if you don't have polynomials, you still have to do something. You still have to do something. Now, let me show you another way of doing that same problem. So limit as x goes to 25, the square root of x minus 5 over x minus 25. And if you direct directly substitute and you get 0 is 0. We did that. Now, let us look at x minus 25. Remember, if you have a squared minus b squared, the things being squared are a and b. Write them down in 2 brackets. One gets a plus, one gets a minus. That's factored. Now, clearly, you know what's being squared there. The answer is 5. So let's clear what's being squared there. The answer is square root of x is being squared. What's being squared here? I ask you, what squared gives you x? You should say the square root of x squared is x. Now, we have the difference of squares. X minus 25 equals the square root of x squared minus 5 squared. So I write down the 2 things being squared. The square root of x and 5, and then I do it again. One gets a plus, one gets a minus. So that's how you can factor the bottom. And then what you get, the limit is x goes to 25. The top is the square root of x minus 5. And the bottom fact is 2 the square root of x plus 5 times the square root of x minus 5. Since x is not ever 25, we just get closer and closer to it. This is not 0 and that's not 0. But they're both the same, so the fraction is 1. So then you just directly substitute into what's left over. 1 over the square root of x plus 5. Well, 1 is 1, and if x is 25, this is 5 plus, and that's 5. 5 plus 5, of course, is 10. And 1 over 10, a lot of students, they write, oh, that's 10. Nonsense. I know it's not. So 10 times 10 is not 1. 1 over 10 is not 10. So you have 10 divided by 1, then you get 10. Because 1 times 10 is 10. So, one problem, 2 ways of doing it. Substitute 4 for x. 2 times 4 is 8. Take away 8, 0. Square root of 4 is 2. Take away 2, 0. Okay, we have to do something. We have to do something. Let me write it down again since I wrote on it so much. The only thing is I'll factor the top. I see I can factor out a 2. X minus 4. And since the top was a polynomial, x minus 4, this minus that, x minus 4, will be your factor. And there it is. Now this is like the last problem. There's 2 ways of proceeding from here. You can think of x minus 4 being something squared minus something squared. What squared gives you x? Square root of x. What squared gives you 4? 2. So it's the square root of x and 2. 2 times you write it down. One gets a plus, one gets a minus. So it's 2 times the square root of x plus 2 times the square root of x minus 2 over the square root of x minus 2. And this cancels out, so you directly substitute. It's 2 times what's in the brackets. Square root of 4 is 2 plus 2. 2 plus 2 is 4. 2 times 4, 8. So here, 0 over 0 equals number 8. You really need to be able to work with these square roots. They will be on the test for these type of limit problems, and also when you come up and you're trying to find the derivative, which is just a special limit, the limit that you use a lot. And now we're going to change the topic to left hand and right hand limits. The limit as x goes to 4 from the left. That means from the left. That is, x is less than 4. You're coming from the left. Here's 4, and you're here, and then you're there, and then you're there. You're getting closer and closer to 4 from the left. All of these numbers are less than 4. And you want to find the limit as x goes to 4 of some function. You want to find the limit as x goes to 4 from the right. Plus means from the right. You're here and then there and then there. You're getting closer and closer to 4, but you're coming from the right. That means the x's are bigger than 4. You want to find the limit as x goes to 4 plus of f of x. And you also just want to know the limit, no plus minus. You want to find the limit as x goes to 4 of f of x. If there is no symbol there, no plus or minus, then is there a chance this limit will not exist. In fact, this limit exists if and only if these two limits are equal. If these two limits are equal, then and only then does this limit exist. If those two limits on top do not equal one another, then this bottom limit does not exist. Last point, big point. If this limit in the bottom exists, that is, if these two values are equal to one another, then this limit on the bottom equals that common number. If this top limit was 72, and this bottom limit was negative 72, or negative 721, then we would say this limit on the bottom does not exist. Because this limit, with no plus minus in the upper right hand corner of 4, only exists if those two upper limits are equal to one another. And if they are equal to one another, then the limit equals that number. When I say the limit, I mean just as x goes to 4, no plus minus. The limit would be 72. If the two the left limit and the right hand limit are equal to one another, then the limit exists and it equals that same answer. So I'm going to give you a graph and I want to answer these three limits. We want to answer these three limits. In fact, I even want to know what f for 4 equals. Now, suppose the graph goes like this. What you see in red, with the exception of one point, and I'll talk about that, only stuff in red is the graph. The only exception is this circle. That means there is no point there. This filled in circle means the point is there. Other than that, everything in red is part of the graph. Not some, not most, but everything you see in red, with the exception of that circle, part of the graph. One and 3, and 1 and 2, and 3, and 4. The first limit. The limit is x goes to 4 from the left. That means we're a little bit less than 4. You know, let us draw it so we have some room to play around 4. One, 2, 3, 4, 5. One, 2, 3, 4, 5. Y and X. Okay. Little bit less than 4. A little bit less than 4. The Y value is at 2. At least that's what I meant it to be. 2. One might argue correctly that 2 should be a little bit higher. 2. If x is, the next limit says, the limit as x goes to 4 from above of f of x. This graph is y equal f of x. If you're a little bit more than 4, if you're a little bit more than 4, you hit the graph right here. And when you go across, you get 4. If you're a little bit more than 4, the y values happen to be a little bit more than 4. This 4, okay? Right? Since these two numbers are different, the limit as x goes to 4 does not exist. Does not exist. If the right limit and the left limit are equal, then take that common answer and put it down there. Okay, now what is f of 4? Well, I go to where x is 4. I look for the graph below. I don't see it. I look above. I go right through that circle because it's not on the graph. And then I get right here. And when I look across, I get what I get. I get 4. So the limit didn't exist, but yet f of 4 was 4. F of 4 existed. Let's look at this other graph. This time things will be very different. F of x. The same questions. What's the limit as x goes to 2 from the left of f of x? What's the limit as x goes to 2 from the right of f of x? And if you study and go into the exam knowing your rules, this one comes for free, because you look at the answers from the last two, and what is f of 2? Well, let's do the first one. A little bit less than 2. A little bit to the left of 2. That is less than 2. Well, a little bit less than 2, you're about right there. And I hit the graph right here, and I look across, and it's 1. It's a little bit more than 1, but then again, I could get closer. I'm not close enough to 2. I can get closer to 2. Okay, and you would start to see that yes, the answer is 1. Now, what if you're a little bit more than 2? 2.0001. A little bit more than 2. You go up to the graph, and what do you know? You get 1. Since the left limit, remember, negative means left limit. The left limit and the right limit, positive means right, are equal. These two are equal. So the limit of x goes to 2 when nothing in that corner of f of x is that common answer, 1. If the answers were not common, we did not get the same 2 answers down here, then the limit of x goes to 2 of f of x would not exist. Okay, what is f of 2? Well, you go to 2 and you look below and above until you hit the graph. And I hit the graph right there. And the y value is 4. F of 2 is 4. Notice, they're not even equal. There's no real correlation to what the limit is and what the limit as x goes to 2 is, and f of 2 itself. I mean, I could have put f of 2 here, or here, or here. I could let it be any number. I can even put it to fill in the whole graph. But I didn't. I put it up here at a height of 4. Look a little bit to the left when it says a negative in the upper corner. Look a little bit to the right of the number if there's a plus sign in the upper right-hand corner. I want to make sure that you don't get confused when it's negative, when x is approaching a negative number. The roles will not change. A plus in the upper right-hand corner, you look to the right. A negative, you look to the left. So, what is the limit? Same 4 problems. What is the limit as x approaches negative 2, but to the left of it? It's approaching right here, but from the left. So I'm going to take a number a little bit to the left of it when I go to figure out the limit. And we'll call this function g of x. And what is the right-hand limit? The limit is x approaches this negative number, but from above, just above. And what is just the good old limit as x goes to 2 of g of x? And I meant to say x goes to negative 2. And what is g of negative 2? And limit as x approaches negative 2. So for the top limit, first limit, go a little bit to the left of negative 2. It's not going to matter because you go a little bit to the left of negative 2, you get 1. If you go a little bit to the right of negative 2, you also get 1. Since I got the same answers, these equal 1. But g of negative 2 want to be crystal clear. G of negative 2 doesn't exist. G of negative 2 doesn't exist. Those two lines are meeting. G of negative 2 doesn't exist. Because if I go above and below negative 2 on the x-axis, I never hit the graph. It went right through the graph here and never touched it. The graph is only what's in red. Up to, but not including the circle. And beyond the circle, but only what's in red. And if you ask me what f of 1 is, I look up, I hit the graph right here. I look across, I see a little bit more than 2. If you give me this point here, that is when x is 2.5, it looks like the y value is 3. When I went to 2.5, I went down and up, and I hit the graph. I hit it right there. At negative 2, I don't hit the graph. It's undefined. You didn't tell me. It's undefined when you don't have an answer. It's indeterminate when you have nothing but answers. Okay, that finishes the second section of the Calc 1 video. Good luck.